Page 14. Rewrite each expression as a product using expanded notation, then identify the base or basis and record the number of times the base is used as a factor. So for A, it's 2 to the fourth power times 2 to the third power. So we know that 2 to the fourth power itself means that 2 is being multiplied 4 times. So it's 2 times 2 times 2 times 2 like this, right? And then 2 to the third power means that 2 is being multiplied 3 times. So 2 times 2 times 2 like that. Okay, so all of them are in parentheses because they're being multiplied. It's not asking us to solve it yet, so let's just identify the base, which in this case would be just 2, because for both of them the bases are 2. So the base is 2, and record the number of times the base is used as a factor. So how many 2's are there? So the base is 2, so 1, 2, 3, 4, 5, 6, 7. 7. So the base 2 is used as a factor for 7 times. So the factor for this would be 7. Okay. And for B, it's negative 3 cubed times negative 3 cubed, or negative 3 times negative 3 to the power of 3, negative 3 to the power of 3. So we would say that it's negative 3 times negative 3 times negative 3. So that was the first part right here. And we also have to have negative 3 times negative 3 times negative 3. So the base for both would still be negative 3. And we have 1, 2, 3, 4, 5, 6. 6 is, so the base is used as a factor for 6 times. For C, it's 4 times 4 to the fifth power. So we have 4 right here. That's nothing's happening to this first 4. But 4 to the fifth power, we just multiply it 5 times. Okay, so that means we still have the base 4. And the base is used as a factor how many times? 1, 2, 3, 4, 5, 6 times. So factor 6. Right here, it's 5 squared, or 5 to the second power, times 6 squared times 5 cubed times 6. So 5 squared means 5 times 5. 6 squared is 6 times 6. 5 cubed is 5 times 5 times 5 times 6. The bases are 5 and 6. Oops. So the base is 5 and 6. And so the 5 is being used 1, 2, 3, 4, 5 times. So the factors for that would be 5. For this base 6 is 1, 2, 3. So 3 times. So moving on to E, we have 9 cubed times 4 squared times 9 cubed, 9 squared times 4 to the fifth power. So this would look like this. The bases are 9 and 4. For base 9, 1, 2, 3, 4, 5, 9, so it's going to be 5 for factors. And for this would be 1, 2, 3, 4, 5, 6, 7. So let's rewrite each of your answers from question 1 as a power or a product of powers. So we have a base here, and factor is 7. So we can rewrite this 2 to the fourth times 2 to the third as 2 to the seventh, because we have the base here and the factor is 7. Same thing for B. We have negative 3 for base, and we have 6 of the negative 3's. So we can say, in parentheses, negative 3 being raised to the 6th power. For C, it's going to be 4 base, and the factor is 6, so it's 4 to the 6th power. D, it's 5 to the 5th power, 6 times 6 to the 3rd power. So 5 times 5 to the 5th power times 6 to the 3rd power. Same thing for this, 9 to the 5th power times 4 to the 7th power. Okay. So what relationship do you notice between the exponents in the original expression and the number of factors? We can say that the number of factors is a sum of the exponents with the same base. So for example, we notice how it's 2 to the 7th power. we have 2 to the fourth times 2 to the third. So 4 plus 3 is 7. So that's how when the bases are the same and they're being multiplied, we just add the exponents up. So it's 2 to the 7. So same thing for C. It was 4 to the 1 power, or there's an imaginary 1. There's nothing on there, so it's 1. So 1 plus 5 is 6. That's how we got 6 here. Okay, same thing for this. 9, and so we're only focusing on the base 9 here. So 9 and 3 and 2. So 3 plus 2 is 5. So it was 9 to the 5th power times 4 was 2 plus 5 is 7. So it's 4 to the 7th. So the rule here is, write a rule that you can use to multiply powers. To multiply powers with the same base, you must keep the base the same and then add the exponents. So mathematical notation would be a to the m power times a to the n power should equal to a to the m plus n. So the a's are just the numbers, the same base that they're keeping, and m and n are different exponents that you have to add. So when we're multiplying powers, we have to keep the base the same and just add the exponents. So this is an important rule that you should keep in mind.